Alright guys, so now we dive into the really fun and insightful part of this, which is model explainability. So what's driving the model's prediction? We're going to run SHAP values, which is the industry best practice for model explainability, to really see what's going on. So the SHAP value of a feature represents its quantified contribution to the prediction made by the model. We're going to fit the explainer to our model and our test data set here. And then it's going to go ahead and it will calculate those SHAP values. This is actually going to take a while to run. We'll kick it off now. And you should see a percentage bar start to populate. But again, this is going to take a decent bit of time to run, maybe 5 minutes or so. And once it gets to 100%, we'll be able to go ahead and check those SHAP values out. Okay, so now that the explainer finished running, let's go ahead and run the next cell here. And this cell is going to plot the SHAP values that were just calculated. Okay, so here are the features now ordered from the highest to the lowest effect on the prediction. So it takes into account the absolute SHAP value, so it doesn't matter if the feature affects the prediction in a positive or negative way. We can see that City Development Index, along with those working for a private limited company, and let's see what else, education level graduate, City 103, training hours, these are all popping as some of the most impactful features being used by the model to make its prediction. Next, what we'll want to do is take a look at the feature's directional effect on the prediction, meaning do higher or lower values of these features affect the prediction in a positive or negative way. So we're going to go ahead and we'll run the next cell here. Okay, so all the little dots that you're seeing on this plot represent a single observation, a single data point from our data set. The horizontal axis down here represents the SHAP value, while the color of the point shows us if the observation has a higher or a lower value. So those blue points are lower values and the red points are higher values. Okay, so stop here to consider what has a negative versus a positive impact on prediction. We can see that a higher City Development Index value tends to have a negative impact on the model, right? Meaning that those living in more developed cities are less likely to be looking for new jobs. It looks like it's the same deal for those working for private limited companies. People working for these types of companies are less likely to be looking for new jobs. Training hours seems a little more mixed, although those with more do seem maybe a little less likely to be looking. So perhaps those with more training hours are actually those further along in their careers who are maybe more comfortable, they no longer want to switch jobs, similar to those with over 20 years of experience. We can see those with graduate degrees are more likely to be looking, and those in City 21 are more likely to be looking. Perhaps the cost of living there is increasing. Remember that these are categorical columns that we transformed into dummies. So for example, city underscore 21 is either a 0 or 1 numeric indicator value. So the red is the high, the 1 value, representing everyone who lives there, and the low value is 0, which is blue, representing everyone who does not live there. So now that we understand how these features are actually impacting the prediction, we can go back to the recruiters and say, hey, start targeting data scientists in this city who don't work for private limited companies with a graduate education level. They're probably more likely to be looking. Or maybe we start targeting people in less developed cities, right? If we look at the City Development Index, those with a lower value are more likely to be looking. Additionally, as you improve the model and integrate new features into it from all of the feature engineering that you hopefully do, there may be even more informative features and insights that you uncover. The model development process is iterative, so it's totally okay to release this model, for example, as a V1, and then go back and improve your data, collect more of it, and thus improve your insights over time in subsequent later versions of your model. I hope you guys enjoyed this, and hopefully you can apply it to some really cool and interesting problems of your own.